Next video we have seen about the material testing and the characterizing techniques. Important contents in these topics is destructive testing, non-destructive testing, macroscopy techniques, macroscopy. In our in syllabus, destructive testing and non-destructive things is enough. What is meant by destructive testing? Destructive testing is to test we break the specimen and find out the mechanical properties of the specimens. Types of destructive test: tensile test, compression test, hardness test, impact test, cupping test. These are all the destructive tests. First we have to see about the tensile test. Tensile test performs on UTM, universal testing machines. In this test, tensile force is applied on specimen by using universal testing machines. The machines arrangements are shown in figure. Base, in the base the two columns are fixed. The two columns are sliding lead screw, sliding lead screw. In that lead screw, fixed heads are placed. In the with the help of lead screw, the fixed head move up and down. The specimens is placed between the fixed head and the movable head. The 3D diagram or the actual diagram of the universal testing machines arrangements. While testing the specimens, we have to select the specimen in proper way. The shape of the specimen should be in circular cross section or square cross section or rectangular cross sections. It should have uniform cross sections. Avoid the sharp corner on the specimens. The arrangements are shown in figure. The gauge length. The gauge length is the testing length. The gauge length is the testing length. The outer radius are fixed inside the fixed and movable head. The smaller diameter is have to test. It is fixed length and its length 5 times to the diameter of the testing. The SN curve, the stress versus strain graph. Strain in x-axis and stresses in y-axis. The elongations take place are shown neatly while the specimens are elongated. First we have to see the size of the specimen. By increasing load, the length of the specimens increase. Further loading, the specimen is increasing. At a particular time, a neck formation is formed. Then the neck have to fracture into two materials. Single material is converted into two materials. By using this testing, we have to find the material properties like strength, ductility, elasticity, stiffness, malleability, modes of toughness, models of resilience. Applications in aerospace industries, in automobile industries, in electrical and electronic industries, medical equipment and material industries, metals and construction industries. The engineering stress is nothing but the load by area. Area should be a cross sections, whether it is circular, rectangular or square. Sigma is equal to P by A. Engineering string is nothing but the change in length by original length, dl by L. Elastic limit, the deformation of elastic limit. This one is the stress strain curve. A, B, C, D, E are the different portions or proportions of the materials. First one elastic, then B yield point, C is the yield stress, and D is the ultimate stress, and E is the breaking or rupture point. These are the different limits. Yield stress, what is the ultimate stress, breaking stress. Toughness is the total amount of energy absorbed by the material before the fracture. Tough. Before going to fracture, how long period the load can act on the particular point. The graphical representation of toughness. Resilience, the same graph, A, B, C, D and E, how the fracture take place. This depends total amount of energy absorbed by the material during its elastic deformation. Then ductility, materials to undergo plastic deformation to else under applied load. Ductility expressed as percentage of elongation, percentage of reduction in area. Percentage of elongation is nothing but change in length by original length into 100. Percentage of reduction area is nothing but change in CA divided by original CA into 100. Malleability is the capacity of material to withstand deformation under compression without fracture. It is associated with compressive forces. These are all the various stress strain curves. Compression, then compression test. The same UTM machine, we have to use the same UTM machine. With the help of UTM machine, the material is going to compress. The compression test is exactly opposite to the tensile test. In this test, compressive force applied on the specimen. Selection of specimen. The space of the specimen ought to be a circular cross section, square cross section or rectangular cross section. It should have uniform cross sections. Avoid the sharp corners on the specimens. The arrangements are shown in figures. Limitations of compression test. Top and bottom faces should be flat and parallel. Accurate measurements of strain is impossible. A machine higher capacity cannot be used for testing small samples, and machine of lower capacity cannot be used to testing larger samples. These are all the difficulties facing while testing in UTM machines. During loading, Careful attention is required. Not useful for ductile materials, only used for brittle materials. Harness. It is the ability of material which is the resist the plastic deformation. Harness test can be carried out with the help of Poldy harness test, Brinell harness test, Vickers harness test, Rockwell harness test. In our syllabus, the Brinell harness test and Rockwell harness test are had to be studied. This one is the Brinell harness test arrangements. The arrangements. In these arrangements, there are anvil at the bottom, loader to load the specimen, then ball indenter are placed at the bottom, reading scales are at the side, different loads, capacities are placed inside the harness testing machines. The arrangements are in 3D views. Ball indenter. The ball indenter tells the hardness of the material. The formula to obtain the BHM value is B is equal to F divided by pi d within bracket d minus root of d square minus small d square. Pulling up and sinking effect. Then we have to say about the Rockwell harness testing machine. This one is the arrangements of Rockwell testing machines like that. Brinell harness, the Rockwell harness test are same type. In these Rockwell extracts, there are different types of scales are there. A, B, C, D and A, B, C, D, E scales. And the indenters in A scales are diamond, minor loading between 50 10. B scale, the applications are copper alloys, soft steels, aluminum alloys and malleable ions. In C type scales, diamond cones are used for steel, ordered cast iron, case hardening steels. D type diamond, same diamond cores are used. Total load 100 kg. Thin steels and medium cases harness steel. Malleable ions. E type 1/8 steel balls are used. Total load 100. Cast iron, aluminum and magnesium alloys bearing materials. Likewise, F, G, H, K, L, M, P, R, S, V scales are used for different types of materials as shown in this table. This one is the formula for to find the Rockwell harness. Advantages in this test, both type of indenter is used, which being advantages of Brinell and Vickers test. Thickness as well as thin materials can test. No specimen preparations required. Separations, grindings and embeddings. Harness value directly readable on optical evaluation required. Measurements of dialects as optical methods. Limitations: it is not always the most accurate harness testing methods, as even a straight enough error in measuring the depth difference can result in the significant error to calculate the hardness value.